We've spent some time discussing what transistors do, but so far we haven't described why they behave in that way. Hopefully this video will rectify that. Before explaining this, it's important to add a little bit more detail to our understanding of the transistor's construction. Again, let's take the NPN type as an example. The emitter here is very heavily doped and the collector less so. The base is lightly doped and importantly very thin, only about 1/150th of the total transistor width. Now, as we've explained before, when the transistor is behaving as an amplifier, the base emitter junction is forward bias. That means it's on. So, like any normal diode, electrons from the emitter, where there is a copious supply of them because the emitter, as you might remember, is heavily doped, make their way into the base. However, this is where things change. Because the base is very thin and there aren't many holes to recombine with electrons, remember that the base is very lightly doped, the electrons sweep across it, and before they know where they are, they find themselves in the collector region. This is more lightly doped than the emitter, so they have good reason to stay there and are attracted towards the positive collector terminal. So the transistor works by a sort of trick. The electrons are tricked into thinking they're heading into a diode, but before they know it, because the base is so thin, they find themselves in the collector region and are swept up by the positive charge on the collector electrode. This explains all the different behaviors which we've described for the transistor in the previous videos. For example, firstly, the current through the transistor is completely controlled by the bias on the base emitter diode and not a voltage on the collector, hence the graph which we've already described. Secondly, the base current is so small because it is caused by the few electrons which combine with holes in the base region. And finally, we can see now why the graph of IC versus the base emitter voltage is non-linear. This is simply because it is a graph of a diode, the base emitter trick diode, which causes the transistor action in the first place.